Ladies and gentlemen, welcome on today's webinar. I'm glad that I could share with you what's new in SCIA Engineer 20. My name is Jaroslav Broš and I will be your host during this webinar. Before we will start with webinar what's new in SCIA Engineer 20, I would like to show with you some housekeeping, how to use GOTOWEBINAR. Your microphone is muted during the whole webinar. If you would like to ask something, you can use questions box to ask questions during the presentation. We will reply you during or after the end of the webinar via your mail. The webinar will be recorded and recording will be accessible on our YouTube channel. If you would like to read more about what's new in SCIA Engineer, you can do that. You can visit our website and go to the what's new and read here all the topics which will be also covered during my presentation. So let's start with it, and I'm going to talk firstly about customer pool edition fault. As you can see here on the map of the involvement, almost all the countries in Europe where we are active have been voting on the items, and as you can see, totally we get 922 participants which voted for ideas in a pool. Thank you for that, and I'm really glad that I see your involvement which help us to form our product. Here you can see which items have been in the pool, and 3 of them with the most votes. The first one got 13% and it's related to the display of reinforcement directions. The second one with 12%, it's about extended summary report, and the last one which we committed to develop has also almost 12% of the total votes. So let's briefly go through the first 3 topics and talk about it. Clear display of the reinforcement directions. You may notice that we have 4 directions for design of reinforcement in 2D slabs, and it can be difficult to find which is which in the model and how to represent the direction with respect to the coordinate system of a slab. So we decided that we can visualize these directions and help you to understand which direction is which on the lower surface and also on the upper surface of the slab. So if you open the design default, change some directions like I have here 45 degrees and 135 degrees on the lower surface for the lower layer, you can see here that this is the direction 1. It's according to the 45 degrees to the x-axis, and then the second direction is 135 degrees. It's really clearly visible which direction is which. In the case that you have designed results and you are just looking on particular directions, you can still see in which direction reinforcement will be distributed. Here you can see the red arrow, which shows that it's really beneficial for you to have such a display to really clearly understand the directions of the reinforcement. The second item was extended summary report for check over steel. I think that calculation report should contain as much valuable information as it could be possible, but not more. So we develop a new kind of report for ultimate limit state, which is called summary report. It displays all necessary informations which are included in steel check. Here you can see that it's just half of the page 4, and it contains all important results of the checks and also all the necessary informations like the member, related beam data, combination key, internal forces used for the calculation of all the checks, all the performed checks, also the information related to the backlink and stability checks and its informations which are included. So it's perfectly checkable, really understandable for everybody who needs to have such a kind of the report and be able to check it. Of course, you have still the possibility, if there is something which is not clear to you in some result of the check, that you can go and select the detailed output and go through all the formulas used in the calculation with all the references in the norm, so you can very easily check what's going on the background. But for the purpose of the documenting for the final report, it's really excellent to have something which is printable on one sheet of paper. The third is automatic calculation of effective width of concrete rib. We have been thinking how to automate routine tasks and be more efficient in the workflow. We already started several years ago with composite structures, where we have implemented the automatic calculation of effective width. So we decided that we will do the same also for concrete structures and implemented the automatic calculation of effective widths for the straight concrete ribs based on the formulas which are included in Eurocode 2. All the calculation is according to the formulas which are written here and also on the geometry of the rib. The benefit is that you don't need to think about the various settings for the effective width. In the past, you have to use two of them. The first one related to the calculation of internal forces in the case of the finite element calculation, so which shape of the cross-section will be presented in the calculation, and then also in the case of the checks you have the possibility to define your own effective width, and it needs a lot of calculation beside our software on the paper or in the Excel table. So we decided that we will create it more automated and, let's say, beneficial for you, that you can directly use it. You can press the button and you will have it. It's very simple. Once you create a structure, you can just hit the button for the meshing, and after the meshing you will see the results of the calculation of the effective width for the ribs. So based on that, you can also do some changes before the calculation, and once you do the calculation, you can use the concrete checks, and you don't need to think about the calculation of effective width for the checks, because everything is done and it's calculated according to the valid code. That was all what I wanted to share with you in the name of user pool, and we will continue the path which we paved with two of the items related to the concrete structures. So let me introduce to you what are the other enhancements related to concrete structures. The first of them is this bill of reinforcement. We developed 3 levels of output for bill of reinforcement. The first level is the most conscious one, and it consists just with the table related to the amount of the material used in the structure. You can see it in the report preview, and also in the 3D window. You can see here the table, because there is nothing to display on a structure. You have very simple table with mass and the volume and the possible other informations. The third one is the level which contains the most details. As you can see here, I have the same information as I have it in the first level, with the amount of the material, and then I have also the information for particular cross sections which are used in the project. Here you can see that I have just 2 of them. I have the rectangle 400 400 and rectangle 600 400. I have also the number of such cross sections or members in a project, length, and some other useful informations. And moreover, what's also valuable, as you can see it here, I have the information about the reinforcement steel which is used in the project in the particular members like B1, B2, B3, etc. I have the number of the type like a stirrup or longitudinal reinforcement, diameter, unit length, unit mass, etc. What's also implemented, and it's beneficial for you in the case of some cost evaluation or estimation of the price of the whole structure, is that you are able to calculate or estimate the price of the structure, so that in the case of the material library, you can include here the price per unit for each of the material, and then this price is applied in the calculation of the price for the materials as well for members. You can do also some increasing of the amount of the material. For example, in the case of 1D concrete members, because of the real shape, let's say, and also in the case of reinforcement bars, because of hooks, because of bends, and because of the anchorage, which is not taken into account in this simple yet powerful estimation. The next enhancement is related to the decreased value of VED, which is used in the case of the reduction of the shear force above the support. So from the finite element calculation, I have such values of internal forces for the shear force. I can go to the concrete settings, think here that I would like to reduce shear force above support, and I have the option that it could be on the face or on the face plus effective depth of the cross section. And here I can see what does it mean in the case of the face of the support or in the case of the face of the support plus effective width. All the background calculation is based on the Eurocode 2 and clause 6.2.1. So you can go to the code and you can have a look what it's implemented. Here it's the final calculation where I applied the reduction on the face of the support plus effective depth of the cross section. So you can see that I'm going here from 187 kilonewtons to 161, and it's on this length. Once we are also talking about RIPs, as I told you in the case of the user pool, it was about the effective width. So we have been thinking what we can do more for RIPs, and we came up with some new layouts for T&L cross-section template. So you can see here that it's very useful for the RIPs to have the possibility just include the shear reinforcement to web, because the rest, I mean, this could be reinforced differently as it is part of 2D slab. So very beneficial. Here you can see for the T-shape how does it look, and in the case of the L-shape, of course, it's in this part, so that there is applied instead up in the part here. That was what I wanted to share with you in the case of the new layouts for the T&L. So stirrups just only in the web. We will continue with such a nice enhancements in a concrete, and that's something which is related to the distribution of corner bars and templates of provided reinforcement. I have such a cross section which is reinforced with such a bars, 4 corner bars, and 2 of them are on this side, as in, let's say, the additional ones. In the case of the version 19.1, you can see this table for provided reinforcement, where I have all the edges of the cross sections plus the reinforcement which belongs to the edge. Here you can count that I have 4 plus 2, it means 6. If you will count how many bars I have in the table, I have 2 plus 2, it's 4, 6, 8, 10. So I have in a table 10, in a picture 6. So there is a difference of 4 bars. And it's because it's based on the corner bars, where I have 2 bars for H4, 2 bars for 3, etc. It could be misleading, therefore we decided to improve it, and in the version 20 you will see this kind of table. So I have on H1 I have 2 corner bars and 2 between. In the case of H3 I have just 2 bars, in a total the 6 bars, and it's according to what I see on a picture of the cross section. So there is no misleading information, no confusion for somebody who is checking the report and see the table and the picture. There is a unity between. It's very nice to have it such a clear output from the calculation. You may wonder why I have this table in such a shape or in the form that I have 1 and 3, why not 2 and 4? And that's a very simple answer, because it's related to the template of provided reinforcement. As you can see here, for the rectangular cross-section for the beam, I have two options. Main reinforcement in Y direction, as I have it, that's the red one and yellow one. That's 1 and 3. The second one, it's main reinforcement, the distribution of the main reinforcement in the Z direction. That's the red one and the yellow one. It's on the side, so it will, in the previous, it will be the 2 and the 4. So I have the full control on the distribution of the main reinforcement, thanks to this two possibilities in the template. So I have the full power and I can switch it if I need to, because of the different conditions coming from internal forces or whatever else reasons. So really nice development related to the improvements of the templates of provided reinforcement and also calculation of the bars. The other beneficial feature, it's called column design by check. In the case of the column where I have normal force and two shear forces, columns are designed with biaxial method. And it's this is state and the plane of the deformation, and the algorithm for the design counts with the fact that the reinforcement is placed in the middle of each edge. As you can see here, it's not optimal because the center is here, there, over there, etc. And it could lead to a big amount of reinforcement just because of the fact that there is some prerequisite for the calculation. And if you have the designed reinforcement, you will put it to the cross-section, then run a check, you will see that the utilization of a cross-section is so low just because of used algorithm. We decided that if we have checks where we are checking the amount of the reinforcement, we can use it also to design such a reinforcement. And this could lead to the fact that the utilization will be higher than in the case of the used design. So here you can have a look that my designed reinforcement in one direction is 800 millimeters squared. In the other direction, it's 1200 square millimeters. And in the case of the check, I can have a look also on the detailed result. That's one of the benefits which I have if I'm using this kind of a design. And here you can see the interaction diagram, and here you can see also the unity check, which is 0.56. If I will use also one of the powerful features called conversion to the real bars, I have this kind of reinforcement, and I will run the check related to the capacity diagram, and due to the fact that I used a little bit more because of the template of the reinforcement, I have the unity checks 0.70, which is mean 70% of the utilization, which is good, and this leads to the economical utilization of a member, and the discrepancy between the design and the check is not so high as in the case of the previous usage of the biaxial design. That's really something which can save a lot of reinforcement material. Once we have been talking about concrete structures, what's also related is prestressed concrete. In the case of prestressed concrete, I'm glad that I can share with you that currently you can calculate prestressed concrete with post-processing environment default and 64-bit version in SCIA Engineer 20. You are able to use prestressed and also post-tension tendons in your structure. We also improved the speed of the calculation compared to the old version, so the calculation is faster. And you can also calculate common or special cases of post-tension projects, like I have on the bottom pictures, which is related to the calculation of the post-tension slab, or on the picture above, which is related to the calculation of post-tension bridge. I have been talking about the calculation, but calculation is useless without any possibility to check what you included in the structure, what you, let's say, designed. Therefore, we have available also checks for ULS or ultimate limit service or ultimate limit state, and also serviceability limit state checks for post-tension concrete. The usage is very simple. You have your concrete beam, you reinforced such a beam and model tendons, run finite element calculation. You get the information about internal forces, about the losses in the tendon, and then you can go to the concrete prestress checks and do the checks itself. Here, in the case of ultimate limit state, you can use the checks which check the bending and the normal force, shear and the torsion, interaction of normal force, bending moment, shear force and the torsion. And we have the same also for serviceability limit state. We are able to check the crack width and decompression check, stress limitation for tendons, reinforcement and the concrete. And finally, we are able to calculate, or let me to say it, to check the compliance with detailing provisions which are published in the code, so that you have ability to check the spacing conditions for reinforcement as well as for tendons. Moreover, what's very beneficial for you in the case of the, let's say, fast checking of the structure is the ability to run all ULS and SLS checks by single click. So you can push a button and you will get all the results for all the checks. Once there is some check which needs your attention more than others, you can select that check and go deeper and see the results which are related to that particular check. Also, if there is something which is not clear to you, or there are some places where isn't insufficient capacity, you can see these warnings, or in worst cases errors, which put your attention to that spots. And you have also a possibility to see some, let's say, resolution or steps which you need to take to remove such warnings or errors. So that's really nice to have such a capability which spots your attention to the places where it needs to be. The last thing which is related to the prestressed structures is bill of material for tendons. And we redesigned bill of material. Currently it combines the prestressing tendons with bill of material of structural elements. So you can see here on the picture with the tables that I have a full possibility to see together. Concrete as a material, post-tension tendons, internal ones, and also reinforcement steel, reinforcement bars. I have also full capability how I can customize such a report as a bill of materials, so I can decide if I would like to see just the concrete or some other items on the list. What I have also accessible in the properties is that I can directly can change the price of the materials, so I don't need to go to the library of materials to change it, but I can play with the numbers here. And here you can see what I already described to you during the bill of reinforcement, that I have a full capability that I can increase the amount of such a material in the project by percentage, so I can add more material to simulate that in my analytical model I don't have so precise model, which is then used for the quantity takeoffs for reporting and some cost calculations. That is all what I wanted to share with you in the name of concrete structures and prestressed structures. There is one item which is made from concrete, and we didn't talk much about it in our presentation, and that's pad foundation. Currently, from the version 20, pad foundation is accessible from 64-bit and from post-processing environment default, so that you can use it in your projects, in your calculation. You can also use the new capability in the case of the geotechnic setup, that you can use the sigma OC, the known soil capacity. Once you have modeled pad foundations in a project, run the calculation, and it behaves like a support. What you also have accessible under the geotechnics, it's a check of pad foundation, and it's all the checks related to the pad foundation, which is published in Eurocode 7, which is related to the geotechnics. And you have the possibility to see the summary of the check, or you have a possibility to see all the formulas and all the references to the code, so that there is something which is not clear for you, that this needs to be changed. You can see the output and find or spot the places where the calculation is done, and see why the result is as is, and you can do the modifications afterwards based on such a knowledge. And finally, we covered concrete prestressed structures. So let's talk a bit about steel structures to make also some steel users happy. What we did, it's not so much, but it leads to the transparency of the calculation, and that's the clear view on a serviceability limit state. So I have a check for steel structures based on the relative deformations. I have drawn the UZ max for all the purlins which I have selected, and I wonder why such a value. I have the possibility to see the length of a beam, and moreover what I can do is also to see the limit settings for variable as well as for the permanent load. So here I can see that the coefficient which is used for the calculation of the limits is 1/360, and that's perfect to understand what's going on in a structure, that I can draw it, I can print the picture and put it to my report, so that for everybody is clear that for such a beam is used such a value. No need to go through the long table and try to map the name of element with the value, where I could have it directly on the picture. That's the main benefit of the development, that if it's drawn, it's more clear than if it's just in the table. As you can see here below, that I have B214 and the value is, but where is B214? Well, you see it on a picture. I know that it wasn't a lot for steel structures, but personally for me, scaffolding is also close to the steel structures, because it could be made from steel or aluminum. It's 1D like most of the steel structures. So let me talk a bit about scaffolding and some enhancement which we did also here. The first thing, we enlarge our library. Beside all the types which we have, we put to our hinge library the Qatari coupler, which is some universal system here, as you can see here, and we have also the nonlinear functions to describe the behavior of the coupler here on the picture in the case of the rotation and the bending moment. So you can use it for your nonlinear calculation once you model your scaffolding and you are using the Qatari system. You can use it and you don't need to specify it, let's say by hand or by the manual input to the nonlinear function. So you can easily select the Qatari system from hinge library, and everything is done on the background. All the nonlinear functions are prepared for you. What we also did, thanks to some remarks, recommendations, we developed the support for the interaction checks 3, which is the check which checks this particular bar here in the case of the connection of this tube to this tube. and we implement it for all our supported types of couplers like couplok, ladder, and Qatari. All the exact formulas you can see in our help and are also visible in the calculation. So this check is now also implemented and could be used. Moreover, and I already told you that you can check the formulas not just in the help but also in the calculation report, and you can see here that if I will select here in the properties that my output should be detailed, I have an option to see all the formulas with all the substitution, with the result, with the units, and most importantly also with the references like the paragraph, table, and it could be found in code. So you have the full capability how you can check your results, that something is not clear. In the case of the interaction 3, here you can see the formulas which are exactly the same as was in the previous slide. So I see here the formula, substitution, and the result, and I know that it satisfies the check that it's below 1. So I'm happy. And that was all related to steel structures and scaffolding. We covered, let's say, all of our materials type like concrete, steel, aluminum. Let's talk a bit about interoperability, about the exchange of data from one software to another one. As you know, we are supporting the direct links with Revit and with Tekla. So let's talk about Revit link update. We are compatible with Revit 2021. What's new is that we are able to export openings as a load panel from Revit. Here you can see that I have an opening and I can just run the export of a model, and in SCIA Engineer I will get opening filled by load panel, and that's useful that in the case of the 3D wind load generator I can simulate that it's window or it's a door if in the case of a wall. What's also a big enhancement here is that we are able to export reinforcement, which is in Revit model, like here, to SCIA Engineer, so that I'm able to export reinforcement for rectangular, T-shape and L-shape cross sections. And this reinforcement then it could be used in SCIA Engineer. Here you can see that I have model in a Revit, and I have just one beam which I have reinforced with the native reinforcement, and I would like to overtake such a reinforcement also to SCIA Engineer. So I can just push a button, the translation of the model is run on the background, and once it's exported, I can have a look that everything was mapped as I want to have. I can close this and go directly to SCIA Engineer, and here you can see that I have such a reinforcement already in SCIA Engineer. So I can do the global analysis of the model, then run concrete checks, Based on the checks, I can increase or edit the reinforcement, as you can see here that I have a full power. I can modify it, and then what's also beneficial, that I can export modified reinforcement from SCIA Engineer back to the Revit and do the detailing. And also what I wanted to share with you in the case of the Revit link update. So from now on, from version 20, we are compatible with Revit 2021, and we are able to do the round tripping with reinforcement. So we are able to round trip the reinforcement for 1D members between SCIA Engineer and Revit without any limits, just as I mentioned here, rectangle, T-shape, L-shape, the most common used types of cross sections. Our second link, our Tekla link and its update. So we are also compatible with the last version of Tekla Structures 2020. That's perfect that you can use the latest versions. And we have, as in the case of Revit, we have bidirectional link for reinforcement in a Tekla. Firstly, we are able to export reinforcement from SCIA Engineer to Tekla, and it's valid for 2D as well as for 1D reinforcement and for free bars. As you can see here, I have a reinforcement in my SCIA Engineer model. I run the transport to Tekla, and now I can do the detailing in a Tekla. So that's perfect that I can do it. If I will start in Tekla, so I have reinforcement in Tekla, bump, I push the button, I have the same reinforcement also in SCIA Engineer, and I'm able to edit it as in the normal case, and I am able to get it back to the Tekla, so I can do the detailing here. The bidirectional link, as in the case of the Revit, it's limited for rectangular, T-shape and L-shape, the most common cross sections. So we are able to do the bidirectional link. So it's beneficial. It doesn't matter where you start. You always use your tools for modeling and design of the structure and do the detailing in your preferred CAD application. And we are at the end of what's new in SCIA Engineer. It was a lot of items on a lot of slides. We spent a couple of minutes to explain it. So let me sum it up here on this slide, that we have been talking about user pool, about concrete and prestressed structures, about path foundation, about steel structures and scaffolding, and lastly about BIM. In the case of user pool, it was the 4th edition. We have developed a clear direction of reinforcement for 2D slabs, summary output on 1A4 page, and automatic calculation of effective width for concrete ribs. I'm glad to say that you are helping to shape our application, and we are working on the 5th edition, so for the version 21. In the case of concrete and prestressed structures, we have been talking about bill of reinforcement, as well as about bill of the material for tendons with estimation of the price, about the economical design of reinforcement for columns, new templates for ribs to help you to create better schemes and designs, and moreover about prestressing in 64-bit version or default post-processing environment with powerful new checks. We have been speaking about the path foundation, that it's available also in 64-bit and in default post-processing environment. It contains improved, enhanced, detailed output, which contains all the formulas visible in the report and references to the code which is used. Steel structures. That was very quick and very simply clear display of SLS limits, that you can see which coefficients for calculation of the limit deflections are used. In the case of scaffolding, I told you that we have a new type of coupler, that it's Qatari, and enhanced checks of couplers, not just with extending of interaction check 3, but also the enhancement of calculation report with formulas and reference. BIM bidirectional links for reinforcement in Tekla, and import of reinforcement from Revit to SCIA Engineer. That's the most powerful enhancements related to our BIM solution. So that was all from my side. Now you can go and download the latest version from our website, from the address which you see here, or it's really easy to find on our website. If you don't have SCIA Engineer, you should try it and ask our trial. It's simply just you go and fill this form. You will receive the trial version, which you can use for 30 days, and then for sure you will buy it, because it's powerful software. Thank you for your attention. Have a nice rest of the day and a lot of success in your projects. Thank you that you attend our webinar. Have a nice rest of the day. Goodbye.